Okay, I guess we are live in time. Hello, everyone who is watching us right now. Hello, the community. It's our third week or third session on the Kubernetes Bootcamp. It's not just general Kubernetes Bootcamp, it's specific one for the two kind of certifications. One is a certified Kubernetes administrator, another one is a certified Kubernetes application developer. We had two sessions before, part 1 and session part 2. This is how we call them. Both previous sessions are available as a recording on the very same YouTube channel which you are using to access this stream right now. The stream itself will also be, it's not recording, it's actually streaming, and the stream will be saved for later as well. Using the same URL, you can always access it and watch again. Okay, I want to greet all the speakers. We are still waiting for one speaker to join, but we can already start quick introduction because I'm pretty sure there are some new people to this call. Ram, we can start with you if you want.
As always. Hey guys, myself Prem, and this is our third Kubernetes session, third and final, hopefully. So we are not going to extend it anymore. And so basically I'm working as a lead DevOps consultant. So I work on cloud containers, CI/CD, so basically like the whole DevOps stacks, and I'm slowly or lately like more getting into data science side of it, and mainly starting with the data ops, but then eventually I think I would be landing into data science. So if you guys have any question around in this topic, please feel free to ping me, or I will be available, or else I will be able to answer to your questions. And yeah. So I'm looking forward for this final session. Hopefully, you guys will get some good insights today. And let's see.
Thank you, Prem. By the way, Prem is a mastermind behind this series of Kubernetes bootcamps. He's the one who suggested it, and probably also the one who is driving it. We have also helpers and peers here. Mitlesh, let's hear who you are, what are you doing? Like, have a please introduction of yourself.
Hi everyone. So my name is Mitlesh. I've been working as a technical service manager and managing one of the clients in distribution sector. Apart from that, I have been also reskilling myself in the area of cloud and DevOps. So I have several certifications under Azure, Google Cloud, and the Kubernetes side, I have a CKA, and I am also certified in OpenShift containers and OpenShift containers and Kubernetes as well. Thank you.
Yeah, basically, Niklesh, he has plenty of certification. He don't have space to store all those things now.
Yes, great. Tito, we are glad you have joined as well. Let us know what are you doing. What's your expertise?
Hi all, my name is Tithonko Shingo. I'm from India. Currently, I'm working in one of the telecom company as a senior cloud and DevOps engineer. Apart from that one, I am a couple of Red Hat certified and Kubernetes CKA certified. So that's all from my side.
That's great. We also have Zubair in the call, who is generally helping out today with the moderation and the streaming. Zubair, say a couple of words about yourself. What are you doing? Where are you from?
Yeah, hi all. Myself Zubair, and I'm a cloud ops engineer, mainly into the AWS public cloud. after this bootcamp, I started going through Kubernetes and with Terraform. So it's helping me as well. I am from India, basically. Thank you.
That's great. Then we are complete. I will just quickly share my screen. We have a document going on. I'm going to post link to the document. It's just a general short guide. It's nothing big, just for your reference. I just posted it into the stream, into the chat of the stream. And I'm also going to share my screen really quickly to let everyone see how it looks like, this document. So here we go. In a few moments, you should be able to see my screen. This is the document which I shared with you. This is what we used from the session 1 through the session 2 and now the session number 3. You will see the dates. You will see the links to the meetup entries. You will be able to read the description of each session. Every recording, which is also the stream, is also referenced here. You will see it here as a YouTube. It's an active link. You can click on it. Another one, here is the brief content, what was going on at each part, at each session. And today we will be covering this part. These 3 topics. Maybe one topic will be extended further a little bit. Let's see. But yeah, that's the plan for today. And you will have a brief overview of each certification which we are targeting with this bootcamp. One is a CKAD, a brief content here, and also CKA, all the most important links. What is not included yet here, but it's here. So this is where you will find the link to the GitHub, which belongs to Prem, and Prem has structured some exercises there for you. You can go through them, but in this session today we will have also a walkthrough through some of them. So that's the plan for today. The link you got, you can keep it. It will be there and will be updated after the session as well. So that's it from my side. And now, as listed here in the plan, we can actually continue with Tito. Otherwise, if someone has any of the speakers, if anyone want to jump in and have something else to say, please feel free to do so.
I think we are good. Let's get started.
Great. Let's get started then.
Yeah.
Hello.
Yeah, Tito, can you hear us?
Yes.
That's great.
Okay, so today we will start from the service, right?
Yeah, your voice is a little bit too quiet. Can you please fix it? Yeah,
it's
it's
okay.
better now. Yeah.
Okay. So I already started my Kubernetes cluster, so it will take some time. So before that one, I will just give a small definition of that service. Service is basically Kubernetes service is basically one kind of object, which is an abstract way to expose our application. So suppose a running pod is running, how to access to that particular pod within that cluster or outside the cluster. So service is responsible for that one. And that service suppose service having three types of, I can say that three types of resources they are using for service. As one is for node port, like how we can means I can say this is not a service resources, it is a service type. First one is a cluster IP, which is responsible to communicating between that cluster. And another one is for node port, which is responsible to expose your application outside that cluster. And another one is a load balancer, which is basically doing the same thing as a node port, but it is another features is it is balancing your load, that whatever the traffic is coming, it is able that load balancer having that capability to balance that load also. And previously another type was it was there, that is the external name, but we are not using that much. Basically we are maximum time we are using cluster IP and node port only. For that load balancer, we are most of the time we using that ingress or any kind of ingress controller is there, and that ingress we are using. So basic let me try to open my cluster so I can
Yeah.
share you.
So in the meantime, right? So let's say
Yeah.
service is nothing but just an abstraction layer. Just consider a virtual layer which will be created on top of your I mean, along with your pod segment, okay? And basically, it just tries to give an IP address to reach your services which is running inside in each pod. So that's a basically use of it. So that's why we call service as an abstraction layer, right? And as Tito mentioned, we have like three different types or modes basically. So let's say, for example, you have two services. Consider you have front end and back end, and you want to have access between these two things on the same cluster. Then you can actually expose node port. And you have two clusters and you want to access two different applications. Then you can go with cluster IP. And if you want to like do some sort of scaling, then you can actually go for load balancer. And if you're not, see, you can actually specify what sort of a type you want to have for your services. Basically, like when you create kubectl service type, you can actually specify like, okay, what you need. Wherein if you haven't specified anything, by default it will be picked cluster IP. So cluster IP is the default function, default mode. Okay, and for node port, there are like some specific range of IPs. I think, guys, correct me if I'm wrong. So it starts with the 3,000, no, 31,000 to the 31,999 or something like that. I don't remember this point, but then when you actually select some sort of one, uh, um, uh, the target port will range between these two numbers.
Yes, it is
And
30,000 to 32,600 767, that port range for node port.
see, there you go. I mean, yeah, that's what it is. So basically, like you can actually specify it, so which it comes as a static declaration. If you don't specify it, trust me, so Kubernetes will pick up on port range between that specific range. It will not go beyond plus or minus beyond that. Yeah, share your screen and show demo.
Yeah. Where is okay. Hopefully you guys able to see my screen.
Not it.
Yes, now we can see it. If you could increase a little bit your font
Okay.
size, that would be amazing.
Yeah, sure. Increase. Is it okay?
Yeah, it already much better. Yeah, that better.
Yeah, let me increase. Okay.
Thank you. That's amazing.
Okay, so before going that one, I am creating there is a one application is there that is called one rocket chat application. So if you I'm just going, it is already created in my machine. So I am that application I am going to expose outside my cluster. Okay, so before that one, that application need a database. So first of all, I am deploying that my application. If you see that application having one replicas, and it has that selector label and selector, it is already covered in previous session. And this is my image, and I have to do some kind of post activity test. So that is the reason I need to mention these things for that application. So if I go to that my application, sorry, let me go to here. Yeah, this application, I am simply running that kubectl create -f. I am using default namespace. So that pod is deployed in default namespace, it is running. So I need, before running that that application, I need to do some kind of pre-installation task. So I need to log into that particular, before that one, I need to create the service also. This is the service. So it is mentioned that I am using for this particular MongoDB, because DB is not, I don't want DB should be accessible from outside. So that is the reason I am using cluster IP. So here, if I mention that cluster IP, it will take cluster IP. As Prem told, if we not mention any kind of type, it will by default take as a cluster IP itself. So by default features is a cluster IP. So but for my easy to understand purpose, I am just mentioning that in that file it is a cluster IP. So I am just creating that service. SVC. So if you see that my service name is this one, rocket chat MongoDB SVC, my type is a cluster IP, and this one is my cluster IP, and external IP is not there. If I will use any kind of notebook, that time external IP it will show means, or sorry, if I use any kind of load balancer like nginx controller or any kind of thing, at that time it will show you that external IP. And this is the port which is mentioned for MongoDB port 27017. So if I expose that one, expose means if I describe that one, kubectl describe SVC. So if you see that name is there, namespace by default, label is none, annotation is not, nothing is there. Selector, that means app equals to rocket chat MongoDB. This is connected, this selector is there. This name is should be available in that application also, MongoDB application which is run, which I am running, that in that one, that label should be there with the same name. So it will be attached with that particular MongoDB MongoDB database or application. This is the IP. I will tell you how to IP this IP will assign. I will tell you that one later. And this is the endpoint. Endpoint means, if you see, this endpoint is, this IP is nothing but your pod IP. If you do that kubectl get po -o wide, if you see, this IP is this one, your pod IP. So this is pod IP, and this one is your port, that MongoDB port. So now I need to go log into that particular DB to do that, initiate that replica set. Otherwise my application will not run. Then kubectl exec -it, then my pod, then /bin/bash. If I for initiate that replica set, this is that Mongo. So I just need to do rs.initiate this is not coming into your means in your exam, but for running that application, I'm just doing this one. Secondary, primary, my job is done. Just checking that one, that my DB is connecting or not. How I need to check? This is my service name, because this within the, as I told you, within the cluster it will connect with that cluster with that cluster IP. So whenever we are accessing any kind of application, we cannot directly access to that particular application. We need to connect to that particular service itself. So here I have two application. One is that Rocket Chat application, another one is that DB. So how it will communicate that application to DB with that particular service. So service, I need to check that service with that particular endpoint, that service itself is accessible or not. So for that one, I need to do MongoDB / this one 27017. One second. At my DB is accessible. That means my application will be connected to my DB. How I checked? Because this IP, this one I need to mention in my application to access that particular database. Now, as a environment variable, I need to mention. Now, if you see my application, sorry. If you see my application, I mentioned that two replicas. Let me do it in one replica. It will be easy to understand. This is the match level I mentioned. This is a level and selector which I used for that my rocket server application. And this is my container name, container port. This is 3000 port, and this is the Rocket Chat which will be used for the latest version. And this is the environment variable. How my application will connect to my DB. There it is a basic connectivity. So I am not using any kind of user ID password. It will, without user ID password, it will log in. So this is my URL. With this URL, it will be connect with that particular DB. And this is my Rocket Chat is my database name. Now let me, as that MongoDB already created MongoDB service also, now I am going to create Rocket Chat application. kubectl create -f. So if you do kubectl get po, showing it is running, but before that one I need to check the log, it is perfectly working or not. kubectl logs -f. So it will take 2 minutes. So meantime I will tell you okay, it is going on, how that service is using your what I tell means that IP. Just wait, hold on. Okay. So as in previous session already I think Prem already discussed about that one, that regarding that Kubernetes component. So there is a component called kubeproxy. As you know that every node in Kubernetes cluster run a kube proxy. In the meantime my application already run, so let me tell you that concept, how this kubectl SVC, this IP is coming. So as you know that Kubernetes having that each and every cluster kube proxy is there. So kube proxy is responsible to implement a form of virtual IP. That virtual IP assigning to this particular whenever you are creating any kind of service, it will it will take that IP from that virtual IP list, and it will assign to your particular service. So now my application already running, so I need to expose that one. I don't want to run it in within the cluster. I want to export outside the cluster, so anywhere anyone can able to access this this application. So to this one to do this one, there is a concept called creating service with that node port. I already created one SVC, but this one is related. This one is related. I need to change it little bit. So never mind. I'm changing that one. Okay. Target port 3000. Port this one.
Sorry guys, I was speaking on mute. So in the meantime, so there are like two level of things. One is like CNI and another one is like kube proxy. So since Tito already touched kube proxy, I just want to tell like what is CNI. So CNI basically just allocates IP for your part. So it accommodates a specific range, and each part gets its own IP. So as we discussed in the previous session, whenever you launch a part, consider that individual part as a separate VM, and each VM will have its own IP, right? So basically, that's what CNI does for our part. So whenever you create a new part, so your part will have a specific IP, and this kube proxy will act as an IP. It will supply IP for your abstraction layer, which is called service, and that's a key difference. Both the things are not same in a way.
Okay. So this one. Suppose I am using 3007. So here I am mentioning my node port. So it will take this 3007 only. So if sometimes if you don't want to mention this one, so it will not so at that time it will take any kind of node within that particular 30,000 to 32,667. If you mention, you can mention. If you don't want to mention, it will take any kind of any kind of number range, port number within that particular range. kubectl create -f. Okay, something is missing, that is expected colon is there. Okay. Pardon.
Unsupported value.
Yeah, notebook name is wrong. I got it.
Capital.
Yeah, capital N I need to provide.
Yeah. So basically, guys, when you don't know something and if something is breaking like this, you need not to worry. There is a command. So kubectl explain. For example, this is SVC. Can you just type like kubectl space
Yeah, just
explain
Prem,
space?
just 1 minute. Let me log out from that my chat, office chat. Okay, just 2 minutes.
Mhm.
Yeah, now I am back. Let me
Yeah.
share my screen again. Okay. Uh, Hope you guys able to see my screen. Now see, when I created a service with that uh, node port, it also provide you one cluster IP, and that it is redirecting from 3000 to 3007. Now I am accessing my what is called, I can say, this application from the browser. Let me share my screen to you. I need to share my particular one screen to you. This one. Now my cluster IP 192.168.101.128 colon 3007. If you open, your application is accessing. This is your application is accessing. Now you can, means whatever you want to do in the your app with your application. So here one thing I need to mention, as I told you, that how this IP is coming. So before going that one, let me describe this kubectl, your this particular IP. You see, this is your IP. This
Um,
is your port 3000.
I
Uh,
I
yeah.
think your command prompt is not visible.
Oh God. Okay. 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 Got it. Got it. Got it. I got it. Hope it is visible right now.
Yeah, it's loading.
Yeah. Now see, if this is my port, this port, this port is your service port. This is target port. Target port means which is when this port is your container, means your application port, and this is your node port. So means 3007. So whenever it has connectivity is coming, it is coming to that 3000 port first in your node port. This node port is redirecting your means traffic to that particular this particular port, means service port. Then this service port is redirecting to your traffic to your target port. So basically it is doing reverse one. So whenever any means coming means like if you typing any kind of means endpoint URL, and you are asking for means trying to fetch that particular data. So first it will hitting to this, it is coming to that 3007 means 3000 port, and that from 3000 it is going to that 3000 this service port, and from the service port it is going to that node port, and it is showing you that result. Now it's coming that from where this IP is coming, this 10.103.54.127, from where it is coming. So basically means as you know that pod IP is assigning their IP for particular pod. There is a IP, as I told you, that kubectl 8po hyphen o white. This IP is assigning by the pod network. Maybe as Prem just now before told you that CNI, maybe it is Calico, whatever that funnel you are using, web network you are using. So basically it is taking from that one itself. And you are mentioning that pod network during that bootstrapping also. So now I am going to show you this, means from where it is coming. So as I told you, if you there is a kube proxy is there. So if you do that kubectl describe cm cube hyphen proxy hyphen n cube system. See. If you go there, this is your cluster CIDR. Okay, so this is your cluster CIDR. Now means that cluster CIDR means that pod is assigning, pod IP is assigning within that particular range. Now if you go to the if you open your your Cube API server, you can able to see your service from where the service IP is assigning. So kubectl describe po cube hyphen API. Let me see that name, full name. I also forgot. Kubectl get po hyphen a. This is Cube API server. Now kubectl describe hyphen n cube hyphen system. If you go there, if you see this service cluster IP, so whatever that IP it is assigning, like 10.103 range, any kind of range, it is assigning from this particular service range, and it is a service cluster IP range. So hello.
Yeah, we can hear you.
Yeah.
Go on,
So
Tito.
yeah, so that every node in a Kubernetes cluster, as I told you that every node in a Kubernetes cluster run a kube proxy, and kube proxy is responsible for implementing a form of virtual IP, which is assigning to your assigning to your service, like in the form of cluster IP, node port, or whatever the range mentioned in that particular Cube API server, that is 10.96.0/24. And another thing is that you can assign your own IP address range also here. Means like I don't want to
Yeah,
use any kind of 10.96.0.0/112. You can change it, but at that time what what will be happen, that address should be a valid IP range, and that CIDR should be a valid IP, cube means valid IP, but valid CIDR. And if you want to create a service with a invalid cluster IP, at that time it will show that 422 some kind of HTTP status code it will show. So basically most of the time we are not changing this IP. This is basically whenever we are installing that Kubernetes, each and every cluster, when maximum cluster, if you search your Cube API server, you will get this IP itself. So from this
it's
range
not only for the it's not only for the client installation, client Kubernetes installation. It is also for your cloud hosted solutions. For example, irrespective of what cloud you are in, let's say AKS, whatever GKS, or yeah, so on and so forth, right? So wherever you go, so the internal IP address will be with the range of 10.xxx slash x, right? So in case if you want to change it, you can still change it, but then mostly it will be starting with 10. And
yeah
you need not to get confusion with that. It's because it is an internal IP address that is used to communicate connections between your parts. And to expose it outside, you haven't separate IP ranges.
Yes. So this is a very simple example to expose your application. So it is sometimes most of the time we are not using notepad, that is a ingress or ingress nginx controller we are using. Ingress, it will come to your exam. I don't know that Prem, you covered that ingress itself in that last.
For CKA, I had ingress. Yes.
Yes, yes, you covered already, so I will not show them
No. I
anything.
mean, ingress, we just did it in oral, like, so we didn't touch anything on the service layer.
Oh, okay.
No.
Okay, so suppose let me tell you that ingress is basically whoever working in cloud, means cloud environment, or or any kind of load balancing features. Whoever know about that one, they can able to relate that one. Ingress is basically nothing but your means it is a basically a object only in Kubernetes, but it is nothing but your it is just help you to balance your traffic, route your traffic properly. It is helps you for that load balancer, and it is basically a one kind of API object. Okay, so basically ingress, whenever when we are doing means using ingress whenever we are want to do expose any kind of http or https routes, we need outside from we needs at that time we are using ingress. To use that ingress, we need a ingress controller also. That without ingress controller, ingress will not work, and without ingress means and it means, like I can say vice versa, means ingress and ingress controller both are working together. So I have an example in the same application. I will if I have that one, let me check. If I have that one, I can show you. Uh, Ingress, just I'm not able to run, but I am showing you that ingress, how that ingress is working. If you see, this is your ingress. Okay, so ingress, whenever suppose if you are typing www.example.com, and you are writing down your ingress rule in that ingress rule in your ingress, means whenever we are creating ingress in that ingress, if you are writing any kind of rule, suppose www.example.com, and if you are mentioning that particular path for slash, it will access your particular this service. Suppose I have means three service I have to access to access my application. Suppose www.example.com, and another one is www.example.com/test, and another one is that www.example.com/test2. So basically what we have to write it here. In the same time these rules I need to create, and this the path, in that backend, I need to create another backend for test 1 and test 2. In this backend we need to mention the service name, service port, that whatever the port, whatever port, maybe 1000 2000 port, and the path should be /test. So whenever I will search for www.example.com/test1, it will redirect your traffic to that particular service. That service may be abcd service. It will redirect to your traffic to that particular service, and that from particular service you can able to access your application. Like this ingress is helping you to route your traffic whenever means what kind of which application you want to access, or which application you don't want to access. Like this ingress will work, and for that one we need a ingress controller to means control your means to manage your load balancer, or means manage your traffic, each and everything. So this is the
So
concept of traffic, but I don't have I don't have any kind of let me take, if I able to create a cluster, create that one, I will show you in meantime, if I possible.
So basically, ingress is nothing but an entry layer for your service. Okay.
Yes.
So, okay, the architecture is gonna be like this. Okay. So you have your path, and the CNI it's on the side. So the CNI associates certain gives supply, or else let's put it in simple words, right? So it supplies IP to your part. Now you have your part has a specific IP. Now, along with that, it has some specific IP ranges which starts with 10.0, right? And that particular thing, now you have like multiple parts likewise, right? So it's all like volatile, and you have multiple parts. Now, in order to accumulate all those parts, you need an abstraction layer, right? So that's what service comes into picture. And service has like three types. Now, this is like internal, right? So it's all whatever we are doing, like it's still on the cluster level, right? So you are exposing a node inside the cluster, you are exposing an IP on top of the cluster, and then you have a load balancer. Again, it's for the cluster, so for the pods, etc. Right? Now, how you will how you will be able to expose those services to the internet? So that's where ingress comes into picture. So ingress acts as an consider like external load balancer kind of a thing, right? So it just gets the IP and gets the request, and then as we are seeing in the screen, like the service name. So the service is underneath it, and then it just goes and hits the service, and based on the path which you're defining, it will go to that path. Let's say consider a scenario, you have multiple services, and or else yeah, with a different path, and you can actually specify it. Or else the scenario could be like, okay, you have a pod one, pod two, and both pods can run on same port, but then the path can be different. So those sort of things you can actually define it here.
So let me share you that how this is working. Let me tell you. Just whatever the service I have created for that my application as a means notepad, I am just deleting that service. Okay, kubectl delete -f. Okay, now I already change it. It will be treat as a cluster IP. See, I haven't mentioned any kind of means what is the type. It will treat it as a cluster IP. kubectl create -f. If you do kubectl create svc, it is a cluster IP. Previously it was notepad, now it is a cluster IP. If you try to access this access this particular application outside your cluster, it will not work. Now to use ingress, so I need a ingress controller. Ingress controller is basically responsible to fulfill your ingress means activity, I can say. Means usually that balancing a node, as I told you, or traffic readout, any kind of thing. So I need that ingress controller. So as my machine in a bare metal, so there is a already nginx already providing different kind of your YML file or nginx controller, which is a compact version. It is coming. So I am just going to that nginx controller, that that link. I'm sharing that link in that chat box, so Jubair or Karin can able to share with you regarding this one.
Yeah, thank you. We will do it.
Yeah. So let me share you. Hope you guys it is able to see my screen, or it is a blank screen it is showing. Means that my shell is showing.
It's showing your ID and
Okay.
shell. Yeah.
Yeah. Okay. So I from there, if I go, there is a bare metal node. Yeah, bare metal is there. This is basically just type here It will directly install install that particular nginx controller in your system. kubectl apply -f, and it is a link for that particular your your nginx controller. This nginx controller basically, as it will be treated as a node port, it will not be treated as a load balancer. Type should be node port only, because I am using bare metal. But if you use any kind of any kind of other environment like EKS or Azure Kubernetes service or Google Kubernetes service, there also a same deployment YML file is there, and you can download. At that time it will be treated, that type should be nginx controller service type should be load balancer. It will show you. So now I
So
am just running.
basically, for exam point of view, you will not be asked. I mean, you will not be asked to do this actually, but it's good to know from the
uh,
technical background of it
but
and
ingress
how.
should be there.
Yeah,
Ingress should be there, but that controller should be already installed. Controller will be installed, but you need to create that ingress for that one.
yeah,
So basically I don't have that controller. That is the reason I am just showing you how to install that controller also.
yeah.
So if you see kubectl get pod, and that namespace, if you see one namespace already created, kubectl get ns, there one ingress nginx, one namespace is already created. This namespace is creating via this YML itself. If you see that with that YML, it is creating namespace, service account, config map, role, cluster role binding, deployment, cluster role binding, role, each and everything, service, each and everything. So whatever we need for that our controller, means ingress controller, it will created all the thing with that particular only one command. So now I am checking that one, my service is created or not. kubectl get svc -a means it will show all your IP. So if you see, there is controller, our controller service already created. This is nginx ingress controller, and this port is 880 port, and that 443, it is redirecting to that particular port. Now I need to create my own ingress, which is coming to your exam if you are lucky. So this is my ingress file. Here I am mentioning, and you can directly, as it is an open book exam, no need to remember all the things. You can directly go to that particular ingress. Ingress means Kubernetes IO, and you can copy it, and you just need to change it as per your convenient. So this is my K8 master is my host name. If we check that host name, this is my host name. I need to mention. Remember one thing: this in that ingress host, we need to mention that host. IP should not be work here. There should be a host name, not IP. Okay, so if you mention like this is K8 master is there, this is my IP is 192.168.101.128. If I mention here, it will not work. It will throw you error during that ingress object creation. And this is my HTTP. I am not using any kind of secrets, anything. That is a unsecure way I'm just using. So this is that HTTP, and this is the service for that Rocket Chat server, and this is the service port 3000. If you see, this is the service port. You need to mention that whatever the port, as I told you in previous way, that port, only port is showing. That port is nothing but your service port, which is need to mention here. And this path is your root directory. As you if you guys are using web server, or if you are working in a web server, so you guys able to know that what is root directory kind of thing. So you need to mention that root directory path here. So basically, which is nothing but your slash, means where it will be connecting, or maybe index.html, it is mentioned there. So I am creating that one. See, ingress controller is creating in your namespace ingress nginx, that in that namespace. But ingress can be object can be created anywhere in any namespace. If ingress controller is there, it will be automatically communicating with the with that particular ingress. So basically, if you have development namespace, if you have production namespace, if you have testing namespace, you can use three different type of ingress to access your application. If you have different type of application is there, testing environment application different, so you need to create each and every namespace in your each and every ingress in your each and every namespace. So basically here my application is in default namespace, I am creating that ingress in the default namespace itself. So kubectl create -f ingress. So this is the depreciation warning, nothing but my ingress already is created. Kubectl get ingress. So front-end ingress already is created. If you describe that one, kubectl describe ingress, it is showing in this scenario. This is your namespace, address is a default backend. By default nothing is there, means it will show you the default backend. No need to worry about that one. But this is your host, this is your host, this is your root directory, and this is your backend, whatever the service, this one. So whenever I will type this K8s master, it will redirecting to your particular, it will call your rocket chat server, which is a service, and from there you can able to, it will connect to your application, particular application. Now if I'll go to open any browser, let me open. I think you guys are not able to see. Let me open again. Yeah, just type that K8 master, my host name. Let me copy it. Okay, sorry, node port, I need to mention the port. Once again, kubectl get po svc -a. So if you are using any kind of means EKS cluster or Google Kubernetes service, you no need to put that port number here. You just need to mention, you need to provide your external IP and it will open. See, yeah, my application is working fine. I'm just providing this port number here because it is type is a node port, so that is the reason. So your application is running. Previously I was using some kind of called node port, but there is no ingress controller, nothing is there. So but this is working as a, this traffic is going through that your ingress, and from that ingress is read out to your particular application. So like this it is working. So you can't able to can't able to see like this, means like how it is, can't able to understand like this, that it is traffic is redirecting, but it is traffic is redirecting to particular your port, particular your pod. So like this ingress is working. So if you are lucky, this question will come. So you need to do this part only.
Tito, we don't hear you right now. Are you there?
Okay, I was in mute. Hello, I'm audible right now?
Yeah, we can hear you now. You're on mute like for 20 seconds or so.
Okay,
And I think you got kicked out or something like this. Yeah, go on.
Okay,
Please.
so as I told you that in that browser I show you, but which part you need to do in your exam purpose, you need to do this part only. Maybe this question will come to your exam, but this part will you need to write this ingress only, and you need to create that ingress, and that whatever that with that host name, whatever they will tell you to browse, that output should be same. Output should become will show you in your window. So like this, ingress is coming. Ingress is nothing but your using as a means yeah, to expose your http or http service, as Prem also told in previously, or that balancing your load each and everything. So if you have huge environment, huge load is there, you have means in your application almost each and every second more than 1,000 user is hitting your application. At that time, this concept you can able to understand how this concept, how it will work. And sometimes here I used basically a bare metal nginx controller. At that time, if you deploy if you use EKS, at that time you can use some kind of application load balancer, also some kind of network load balancer, also based on the situation and based on the requirement. So that's all from the service side. It's if you have any question, just let me know. Or Prem or Mithilesh, if you want to add some kind of some topic, you can mention here also related to ingress or service.
I think it's quite a lot. I mean, it's good, man. You covered a lot of other extra topics as well, which is good. I think we are good. Let's move on.
Yeah, let's move on.
Yeah, and just general remark to everyone who is watching: if you have any questions whatsoever, don't hesitate, post them into the stream chat, and we will address them with the speakers. Thank you. Let's go, Tito.
Yeah, so another topic I just wanted to I don't have that practical here. I don't have that practical scenario right now, but I wanted to mention here, which is a very good topic in purpose, or in, if we say that someone is going to CKA exam. So there is another object, or maybe another question will come, kind of network policy. So that network policy is basically nothing but like, if you guys using any kind of cloud, maybe AWS or GCP or maybe Azure, we are using some kind of means one type of concept is calling security group, which is basically allow, means basically your means firewall to allow your particular port, or means or maybe deny for a particular port, kind of thing. So security group access, ingress or egress rule we are using. So in here also same kind of means same kind of things is there, which is we are calling as a network policy. So if we want to allow or deny some kind of port, or maybe some kind of IP, or maybe some kind of means namespace, any kind of things. So at that time we are creating that network policy. Network policies helps you to do that, means to create you that ingress and egress rule for your particular application. So this is a one concept is there. It is basically very easy. If you go to that Kubernetes IO document, if you find a find a one solution kind of thing, that how to create that network policy, it is very easy. You can go there, you can means you need to mention kind of things, kind policy type, you need to mention ingress or egress, and that basically we are using that egress should be open to all, means like egress should be because egress is going outside that means outside the traffic. So we are not basically using any kind of rule for egress. So the maximum time we are using that ingress rule only to block our port or block our traffic from the particular IP or maybe for whole network. So you can based on the scenario you can mention you can create your network policy at that time. So this is that one very useful topic, or maybe that question will come to your CKA exam. That, and if you say that if I tell you that means that communication is happening for that network policy, like other pod are allowed to whenever we are creating that network policy, at that time we are means we are following three identifier. We are all, I can say we are mentioning three identifier. One is for that other pods that are allowed, and namespace that are allowed, and IP blocks. We need to mention three things during that network policy creation, and based on the situation and based on the question or scenario we are creating that network policy. It is a very easy means that this one network policy to understand. And now going to that next topic, that networking. Kubernetes networking is a very means very difficult topic, or that Kubernetes network, how that cluster networking working, how that every means communication is happening. So basically cluster networking means I can say networking is that mainly the central part of Kubernetes. So that means there are four type of, if you means if you learn that cluster networking, if you will see that there is four type of networking is there. One is that pod to pod communication, as I told you, within the cluster, how that one pod should be communicate with that another pod. That pod to pod communication should be there. Pod to service communication, that I already shared to you, means I already shared to you how that service and pod is communicating with each other. And another one is that external to service communication, and another is container to container communication. Like container to container communication, if I say, like in that particular pod, basically we are using a single container for a particular pod, but sometimes we are using multi container pod also. At that time if there is a container to container communication, we are using that it is basically a local host communication. So this four way this cluster networking is happening. And as you know that we need to use some kind of CNI also, that already Prem told you that interface, networking interface we need to use. So in that Kubernetes, there is many we are using different type of CNI is there, but most of popular CNI, or I can say that means we are using, that is a Calico, maybe it is a Funnel, or maybe it is a wave network. So most of the time we are using Calico only. So each and every CNI having different of pod network means range is there. So Calico is basically a open source and open source networking, and it is providing that network solution for your container, or maybe I can say virtual machine, or that cloud native host based workload. And where Calico supports multiple data plane standard Linux networking data plane, and which is very popular. And Calico also provides full networking stack whenever you need. So Calico is the most popular one as of now, and we can use that Funnel also. how that funnel is funnel is basically, if I say that funnel is basically a overlay network, means that means like it is just for, yeah, I want to deploy a simple cluster, or I can say simple, I don't want to go for much more requirement, I can simply use that funnel. It is just basically overlay network that just means that fulfill your requirement, Kubernetes requirement. And sometimes are also Google Cloud also provides some kind of network, CNI also. Google Cloud is there, CubeOVN is there, Cube router is there, so many CNI is there. So CNI is basically, if means as already Prem already covered that one, so I am not going there much more. And what I will tell rest of the thing, okay, DNS, I will tell you how that DNS will work. It is another good one, DNS service. So as you know that for in our Kubernetes creates a Kubernetes creates a DNS records for your service and pod, whatever you are using. So that means like you can use that DNS name also, is DNS name also to access your particular pod or service instead of using that IP address. So how that DNS is working? So whenever means DNS is, as I told you, DNS is using two types of records. One is that service, another is pods. So how the service record is means it's there, how that service record is used, means it is fetching that service record. So first of all, if the DNS record, whenever we are using any kind of means creating any kind of DNS server and we are using any kind of IP, we are mentioning that against that IP we are mentioning www.example.com. This is my DNS name. If we do that NS lookup, it will, whenever I am running www.example.com, it will show you that IP. So that instead of that one, that www.example.com, it is a general term. So in that Kubernetes, that DNS record something a little bit different. Like if we say that one, I have a one service that is my service, that for that particular my service, that DNS record should be that my service, that this is a service name. Then that one namespace should be there. That is namespace, maybe that default, maybe any kind of namespace, whatever the namespace. Then should be .svc. svc is nothing but your service name. And then it will be, there should be a cluster domain, and then another one is .example. So if I share you that one, how it looks like, kubectl get svc. So this is my service. That for particular service, the DNS record should be like this one, .default .svc .cluster domain .example. This means like this one is my DNS record. Its DNS record is creating with that like this way. So it is for service. So if we use for, if we go for pod is something kind of different scenario is there. So in that pod, that we are not using any kind of pod name in that during that pod. In that pod we are using, suppose we have a pod IP, suppose kubectl get po -o wide. So in that pod, that for particular this pod, that DNS record, it looks like it should be like 10-244-1-101 dot namespace default dot pod Suppose after that it should be whatever is your domain name, cluster domain dot example, it should be, or cluster dot local, like this it will show cluster dot local, or maybe cluster example, or dot example, like this, that DNS is working. Let me show you in one example, if I have that, how that DNS record I can find it out. There is a busy box is there. With that busy box we can able to find it out. uh, Mithilas, do you have that Mumshat course open, that cluster?
No, I have no, play with Kubernetes.
Okay. Okay, so I don't have that example right now, but that's all from my side. I think over to you, Prem, that if you want to add some, you can go for other topic also.
Yeah, it was seriously awesome, man. I mean, I didn't think like we would be covering a lot more in detail actually, but you did it a lot. Yeah, so good, good insights actually. And next, yeah, we're just gonna see about config maps and service accounts and security context. Yeah, and these things are important for exam point of view. Maybe you can just skip service accounts, but then the other things are like pretty important. At least config map is really important for CKA. So basically, we have covered how we will have a persistent volume and persistent volume storage and all those stuff claims in the previous session. And so this config map can be also done in very similar way, and that's what Mithilesh is going to show us now. And yeah, Mithilesh, you can just.
Thanks, Prem. Thank you, Tito. I think that was really great. I mean, it is very difficult topic, service and networking. So it was really good that you have covered most of the things there. So I'll be covering. Am I audible?
Yeah.
Yeah, so I'll be, there are some topics that were left from the last session. One of them is static pod, daemon sets, and then config map. So static pod was, I think it is one of the important topics from the exam perspective as well from CKA. And I think I remember that it was there in my exam as well. So I think it is good that we understand a bit about the static pod. I'll share my screen. Is my screen visible?
Yeah, coming up.
Yeah, we can see your screen now.
Okay. So about the static pods. So static pods is when you want to run the one specific pod into one specific node. So we had discussed previously about the different components, like you can make the request through kubectl to API server, and then scheduler finds a node for it to run your pod into. But there is another way that you can run the pod is using static pods. So suppose if you want to, this is a pod and you want to run this pod on this node without sending a request to the API server. So how you can do that is via a Cubelet. So as you must have noticed in the first session that Cubelet is the captain of this ship. So it is like captain of the ship, and it manages everything on a particular node. So using that, we can schedule the one particular pod into one specific node, and I'll show you how to do that. So this is my master node. If I say kubectl get nodes, Sorry. Basically, I have 3 nodes here, 1 master node and 2 worker nodes. And I want to schedule my pod into, say, one of these nodes. Okay. Anyway, so say I want to schedule my pod into this node. So how do I do that? Using the kubelet. And where is that kubelet configuration? That is in varlib kubelet of that node. So you see that there is a config file here. And in this config file, you can see the mentioned static pod path, which means this is where the if I put my YAML file into this location, then my pod will be scheduled in this node. So let us do that. I go to yeah, you can see that this has come up. We have 1 master node and 2 worker nodes. So I'll just create a YAML file. I'll say oops. So I will take this YAML file, go into this node, and in this location, I paste my YAML file. Now I go back to master and see what is happening. So you see that I did not create this pod here, but I just put in the YAML file in the node 2, and it is creating the pod in node 2. So this is how you can create one static pod. So this is one of the question also could come in the troubleshooting section. So say this path is mentioned here. And if you this path may be given wrongly, or some spelling mistakes, or this path is empty, then you don't know where to put the YAML file into when you have to create the static pod, and that is where you have to troubleshoot that what is the issue. So you can go to this location varlib kubelet. There you have the config file where the static pod path is mentioned. So you can see if there are any issues there. And this, it may also happen that this path which is given is different. So if it is a different path, then you have to put your YAML file into the path which is mentioned in this configuration file, and then the pod will be scheduled there. So you can see that now the pod is running in node 2. And it is also appending this node 2 on the name so that you know that it is running in node 2. And if you want to verify, you can also check it. You can see that this is scheduled on node 2. So this is how you can schedule your static pods. This is one of the best use cases when you are installing. So if you are using kubeadm to install, then the components are installed as static pods, because when you are initializing kubeadm, there is no API server. So it is not able to do it via API server at that point of time. So that is where the static pod comes into picture, and that is one of the best use case I can think of. So that's about the static pods. The next thing is daemon set. So daemon set is one of the controller managers, one of the controllers in Kubernetes. And daemon set is used where you have to schedule your pod into all of the nodes. So why do you want to do that? Is suppose you have to collect some logs from each node and you want to install something like Fluentd for collecting the logs, and that's where you want to install the pod into all the available nodes. And that is where daemon set comes into picture, and it will help you to schedule the pod into all the nodes. So let us see that by an example. I have a YAML file. So this is a simple YAML file, and so this is a simple YAML file for creating a daemon set. I will run it. Is something wrong?
Mithilesh, there is a dash, missing dash, app slash.
Okay. This one, right?
Yeah, this one.
Okay. Thank you. No. Shall I say validate? The same thing was running fine. Oh,
I think labels also you missed that colon. There is no colon is there. Means labels app colon test env colon prod.
okay.
Yeah,
This is
so
missing.
basically
Yeah.
it's unlinting issue.
Yeah.
So just
Yeah.
try to check your lints, and that should work.
Yeah. 1 second. I will come back. Meanwhile, you can continue if you have something to share, Prem or Tirtho. I'll come back in a minute on this.
Mhm. Okay. Do we have any questions on the chat?
No, not really. It's really quiet in the stream right now.
Okay, so let me quickly share some of the key scenarios which may come in exam. I'm just trying to spin up on a new cluster, so we'll take like 2 minutes to 3 minutes, and then I should be good to go. So let me share my screen in the meantime. Once it is running, I can just
Kicked out of the call, but we should be good now. So if you want to share your screen, you can do it now.
Is it visible now?
Yes, it's visible. The font is of the right size. It's big. We can read it.
Okay.
And sorry, everyone, for the glitch. We can continue.
Yeah, so this is my daemon set YAML file. So this is a simple daemon set YAML file, and I will run this. I had some formatting issues, which I have corrected. So you can see that this daemon set is created. So if I say so this is it is trying to schedule one pod into each of the nodes. I think something is still wrong. Anyway, so this daemon set is this when you create daemon set control, I will just explain that this is going to whenever you create it, you have your pod running into each of the nodes. So if you have I have 2 nodes now, so it is running in 2 nodes. If you have 3 nodes, it will then start running, and the 3 nodes. If you delete one node, then it will delete one from that node. So that is how it works, and this is basically mostly used for collecting logs as one of the use case, as I can see. Okay, so I'll go to the next thing, which is config maps and secrets. So these are two ways you can pass on the information on when you are running your pods. One is called config map and another is called secret. So basically these are similar things, but one of the important differences is that in case of secrets, it is encoded. So your information is when it is secret, your information is not visible, but if it is config map, it is information is not encoded and it is visible. So I will show an example here. So let us create a secret. So I will just create a username and password. So you can see that your secret is created. Now, if I say kubectl describe so you can see that this information is not visible. But if I create a config map, say I say kubectl create config map from
नेक्स्ट मंडे ट्यूसडे वेडनेसडे मेरा एग्जाम होगा
So I have created a config map now, and if I describe this, you see that this information is clearly visible. So basically, if you are mentioning something, suppose you have different environments your pods is running on, and then you want to pass on something like environment equal to prod, or environment equal to test, environment equal to UAT. This information is not does not need to be secret. I mean, it is not something very confidential, so it can be passed on as config map. But if it is a password, as I have shown you in the previous example, if it is a password, say your database password which you are passing, then you should not make it public, as if anyone can describe and find it there. So that is where you are using a secret. So basically similar things, but two different ways to do it. So I think that's all I have for now, Prem and team. Do you have anything to add?
No, I think we are good. So with this, we have completed all the topics which are needed for CKA and CKAD. And yeah, so if people have some questions, we can answer them. If not, they have their, they got the live session recorded in YouTube, so they can just watch whenever they want, and whenever we see certain questions, yeah, we can reply to them. So I think they're good. Thank you guys. Thanks for all the effort. And it was like 3 continuous weeks. And yeah, so it was very good thinking actually.
Indeed, thank you. Thank to all the speakers for sharing your experience and knowledge with everyone. That's amazing. Meanwhile, we have a question in the chat. Let me read it. So Fazela Yasmin is asking, hi, I'm completely new to Kubernetes. Know some basics of Docker. From where do I start? Please, can you share some resources or a path?
Okay.
Any ideas? Yeah.
Yeah, I mean, there are like a lot of tutorials available, but then I would suggest them to start with the Kubernetes document. So basically, if you just go to Kube, maybe I can just show you quickly. Because the Kubernetes document will go on step-by-step basis, you know.
Yeah, but just to add to that, I think as she mentioned that she is new, so probably I think it is worth to start with Docker, and then she can move on to Kubernetes.
Yeah.
Prem.
So basically,
Yeah.
this is the one which I would prefer. So they need to know the core concepts. So if they just go to this page, so I mean, either kubernetes.io or else it has an CNAME. So basically, like kubernetes.io, and then they just need to go here. If they go here, then it will cover. I mean, they have just given in a way that like okay, from basic to advanced, right? So start. I would suggest to start from here. And once they know the basic concepts, like okay, what is Kubernetes, what is pod and EAP, and so on and so forth, then they can actually look into like a lot of tutorials. For example, Murshid Mohammed course or Sanders course on Orly. So there are like a lot of good tutorials available, so they can also follow that. Because if they want to learn by themselves, then this is the best page. It says like what is it starts from what is Kubernetes to like how to work on a mini cube, and then how to set up an production ready environment, and then it just continues, you know. So like trainings and so on and so forth. So they can actually do a lot of things with this. They can actually cover a lot of vast topic also, and they actually do this particular topic. It will cover a lot. So all the topics which we discussed today, especially, it will be helpful when they actually do their own cluster setup.
Yeah, absolutely. There are so many free resources to start with and explore Kubernetes and learn about it. There are also online class or online courses, free online courses by the, how is it called? Free Code Camp. You can look it up on YouTube. Everything is on their channel. They have a few sessions on Kubernetes alone, and just all in all, there are. But I think it's also a great advice from Mitlesh to start with Docker to get the basics how containers work. And Docker is the main container provider and platform in the world, pretty much. But Kubernetes is not only applicable to Docker; you can run any type of containers. So yeah, and Prem, thanks a lot. Like documentation is a no-brainer, right? You can always start there. It's very good structured. Like Kubernetes is one of these projects where probably thousands of the eyes are looking at it. So the chances are that there will be bugs fixed or the structure will be improved are very high. And it also reflects on the quality of material about this whole orchestration platform. Cool. Meanwhile, we have some latency going on between the call and between the stream. Meanwhile, we received a question related to the last topic, which is, it's coming from Ruben. The question is, can we store in Configmap's configs for our application? And in
Yes,
which format it will be stored? In which format it will be stored? Okay.
So basically, let's say you can store, and in which format I'm not I'm not getting that question. Basically, like, see, if there isn't secret, you can actually encode it, and then you can do it in that way. But yeah, in general, it will be like JSON, and you can also convert that to one YAML.
Also, to add to that, there are two ways you can use Configmap. So one way is via volume, and one way is via the literal. So when you have something like you have an MJX container running and you have different environments, and you want to print a message saying that this is prod environment, this is dev environment in your index.html, so you can use as a volume, and then you can run that accordingly so that it gives proper information. So that these two ways you can use it.
So the time when you add your configs and when you reflect it at the backend, it will be saved as in JSON, so you can actually see it. I mean, for example, if you have your config map, if you have created your config map like configmap 1, and if you just describe like, okay, kubectl get cm config map 1 -o JSON or YAML, so you will actually get it in that format. So that's how it works.
Great, thanks, guys. Here, Mitlesh, I think you have tried to share some kind of link to a basic Docker course. It didn't come through. I don't know. It's some limitation of YouTube chat. Can you try to share it again? I granted you some administrator rights, so the chances are higher now. If you could share the link, would be great.
Did it work now?
Yeah, we can actually see the link now. Thanks a lot. It's on Code Cloud.
Yeah,
right?
so this is a free course as well, and it is a very good introduction to the Docker. So if you don't know anything about the Docker, I think this is what I had followed last year when I was learning about containers, and this is really good.
That's great. Thanks a lot. Here, just adding to the conversation, Ruben is also mentioning that the channel called Tech World with Nana is also very helpful. You can look up a lot of courses there. I also heard about this channel a few times before. So yeah, this is just one of the advices to Azela. And I guess that's it for now, right? Everyone.
Yep. See you guys. Drop off.
Yeah.
Let's see each other on some other session in future.
Absolutely. Let's come together for the next session at some time in the future. Yeah. If there will be any ideas, any speech proposals by anyone in the community, feel free to reach out to admins and suggest. We are open to anything.
Yeah.
I want to thank again Prem, Mitlesh, Tito, and Zubair also left already. Thanks everyone for contributing, for sharing your knowledge. That was a huge pleasure to work to do it with you. Everyone, thanks for attending it. So just last words to you guys, the speakers.
Yeah. No, okay. No last words. Let's see in some other session. See you guys.
Okay. See you everyone. Take care.
Thank you. Thank you so much. Thank you.
Bye.
Have a good. Bye bye.
A computer.
Bye bye.